Okay, today I talk about the basic concept and implementation method of neural network. So actually, so in this talk, I focus on human intelligence. This is really important. Maybe so you can use artificial intelligence library very easily now. But before using AI library, please use your brain. Okay? So today, so I talk about how to use your brain. Okay? So this is today's question of what is intelligence? What is artificial intelligence and what is a neural model? Okay, thank you very much to my friend, my colleague, and my student. Oh, where is Chanshin? Can you find? This is human intelligence. Okay. Okay, this one. Okay.
这是人类智慧，他讲人类智慧跟计算智慧，什么是 AI， 什么是智慧。然后从最基本的观念来讲，我在那边嘛，我们找了一下，我本来去找那个大张的 first I found these two, but no, over there.
Yes, here. So where is oval? Let's see. Oval. Where is oval?
Yeah, I found. My wife also. Oval. Where is your wife? 大宝老师跟他太太。
Okay.
My wife is. Yeah.
Okay, so this is human intelligence, okay? Okay, so I have developed many different types of robots and its related AI systems until now. Okay, so I skip the details. So tomorrow I will talk about the details of robots. Okay, so we started the research collaboration with Chanshin more than 10 years ago. Since then, so we have dealt with human-robot interaction, human-robot communication, and human-robot co-learning. Okay, the robot is very important to enhance the human intelligence, I believe. Tomorrow, I will explain that kind of idea. So today, so I just show some examples here. Okay. So you can go back to the history of artificial intelligence. Maybe so you took a class on basic AI before. Therefore, so I skip the detail. But please don't forget the turning point. So recent turning point. So one is deep learning. Okay, deep learning can realize so visual intelligence. Okay, and then so several years ago, transformer can realize human linguistic intelligence. And now, okay, Professor Chanshin Lee, so Lee Rousey, so deal with quantum computation intelligence. So we don't know the future direction, but we have to understand the importance of human intelligence, and then so we try to realize human intelligence in real world application. Okay. So mic is off, okay. Okay, no problem. So I don't use the speaker. So okay, so I have to share again.
分享是吗？好 ，Yes, this one.
Okay, that's fine. Okay.
而且朝鲜你要在这边，不然等一下回不来。
It's okay. I'm sorry. So I don't.
没有声音，它这个是有声音的，可是它现在播不出来。它是一个影片。
No sound. Yeah. Okay. No problem. no sound is no problem, but okay, so
echo.
the size of this screen. So could you?
就是把它那个
Okay.
全屏幕。
Selfridge. Okay. So he is very famous researcher. He discussed the importance of human thinking, logical thinking. So in 1960s, so what is the process of thinking? But so in this movie, he said, so machine don't think, machine don't understand or something. Okay, please watch this movie. This is really important. Okay, so anyway, I skip this one. So what is artificial intelligence? Can you define artificial intelligence? Okay, so,
华体美丽华体 you can explain what is artificial intelligence？ 什么是人工智慧？每边 I one student， 什么是人工智慧？用中文讲，用英文讲，用日文讲都可以。什么是智慧？他在讲什么是 intelligence？ 其实智慧是很难定义的，每一个人的定义都不一样。AI 你看几十年了，到现在都还没有讲好的。它其实就是人工智慧。就是体力，你可以解释吗？不行，那谁可以？我来。
Okay, no problem. So when we refer to dictionaries, okay, so we can find many different definitions. Okay, so in this definition, the computer and also for normal. What is normal? Okay, so here human mind and also problem solving. So here robot. Here abstraction and creativity. Okay, this is a point. So if artificial intelligence is defined well, all dictionaries use the same one, but different. Why? It is very difficult to define artificial intelligence. Can you define AI? I hope so. You can define AI after my talk. Okay. So I like this idea about intelligence. So biological intelligence, artificial intelligence, and computational intelligence. Of course, in order to realize biological intelligence, so we try to build the basic idea of artificial intelligence. But in the original artificial intelligence, AI, so try to use top-down external description by using symbolic processes. On the other hand, in our research, okay, we try to use numerical data and also symbolic data or linguistic data. So here, computational intelligence uses bottom-up internal description by using numerical processing. Okay, so this is really interesting. So AI and so CI, computational intelligence, these two are very similar, but their original method is quite different. Okay, so in this way, so you should check the original meaning of AI, BI, and CI. I skipped the BI, but I will discuss the biological intelligence. Okay, and then so I try to find several important intelligent technology or methodology. So you can find some intelligence here, and then Obo Sensei Obo Rausi discuss tacit knowledge, tacit intelligence. Actually, so human can deal with implicit knowledge and explicit knowledge. So tacit intelligence is very important for our human communication. Okay, and now, so I go on to the definition of intelligence. Okay, so I always refer to American Heritage Dictionary. So this is very nice for me. Okay, so what is intelligence? The ability to acquire, understand, and use knowledge. Okay, what is understanding? So it is similar to the definition of intelligence. Therefore, I changed mine to discuss about intelligence here. So what is cognition? So our cognition is very important to discuss human understanding. Okay, so here you can find the keyword of perception. Oh, what is perception? Okay, the process of perceiving something with the senses. Oh, what is sensing? To become aware of. So in this way, if you continue using the definition in the dictionary, you never reach the essence. So we have to discuss this keyword with real world phenomena. Okay. Now, so I show one example. So have you? So did you join? So my previous classes? No. This is the first time. Okay, just only you. Okay, if so. Okay, so draw two lines. Okay, two lines. Divide this point.
来画两条线，同一条线把这些点把它分成两个
Two lines.
两条线，你们怎么画？你看颜色，看那个。
Okay, this is my answer. Do you agree with me? Okay, please raise your hand. Okay, so I never asked you about the
你
details.
们同意吗？如果这样画两群，你们觉得 OK 这个地方
Oh, no, nobody agree with me.
？Only one.
Okay, okay. How about this? So draw one line to divide.
一条线，你们会怎么画？华姐，你要怎么画？这样。
This is my answer. Do you agree with me?
同意。它就是一个同样，其他你们觉得要怎么画？我不知道。
Okay, yeah, this is human intelligence. AI cannot do it for us. Of course, so if we use the high level of AI, the AI can do it. Okay, so here, so in this example, okay, we pay attention to the closeness of data distribution. Here, we ignore the color. Okay, on the other hand, we pay attention to color distribution only. Here, we don't pay attention to the closeness or the density of the data. This is human intelligence. So in these two examples, we focus on different type of features. So overall, so he explains the importance of attention. Okay, human attention is really important.
那我有可以声音。
Yes.
我用中文解释好了。然后它的智慧，什么是 intelligence？ 其实 AI 方面都还没有明确的定义嘛，他们是列了很多嘛。然后现在就是你要用两条线来把这些资料分群嘛，好像两条线就这样。那这个是人类智慧，那是 AI 是不会这样做的。AI 比如说不管你学 CNN 啊，你学各种不同的一个分类分群的方式，就它用数学这样算嘛。那一个是一条线就用颜色嘛，就用颜色。所以他在讲人类智慧跟机器智慧跟人工智慧的差别。人类智慧其实人类智慧是几千年的智慧了。那人工智慧是不到100年，人工智慧不到100年，从图灵那时候，对不对？那机器智慧也是机器学习，也是这几年的。那所以我们在讲说，九把田老师就是你用人一看就这样分两条线就分群嘛，把这样把在一起的距离比较近的就把它分成对嘛，对不对？那这一条就是用颜色嘛，你看九把田老师涂颜色，他等于就举其他的生活上的例子。我不知道你们没有听懂，是没有听懂还是没有兴趣？可是我是跟九把老师讲要听懂。那一个就是语言的隔阂，两个的共创。那所以我们希望说可以用自己的语言来沟通来学习。未来用日文，他讲的那个短的，这是我们现在在做的。So I just explain the full night and one night. Yeah, I think maybe the language. Okay.
Yes. Okay. So maybe so so Bateson, so he is a scientist and philosopher. He defined information. So what is information? So he discussed the definition of information. Information provide us with a difference which makes a difference. So, and now, so I also define so information like this. A physical difference which makes a perceptual difference, okay? Okay, now, so I will explain a little more. So here, so we can find 3 clusters here. At that time, if we try to divide this data into 3 clusters, how can you divide 3? So 1, 2, 3. So how can you divide 3 clusters? Or maybe difficult. Why? So if I try to divide this data into 3, so 1, 2, 3. Maybe so 4 is better. 1, 2, 3, 4. Okay. So here we use some importance parameter here. So weight parameter. So in this example, we focus on the data distribution. So we just obtain this result. But so we may focus on something colorful here, and then we can obtain. At the time, we ignore a little about the data distribution. So how about this? So in this example, so we focus on just data distribution. We ignore the color information here. On the other hand here, if we ignore the data distribution X and Y, so we never draw the line. Therefore, so we still need small attention to data distribution, like so epsilon, okay? By changing weight parameters, so we can solve this problem. So we can easily change the weight parameters to solve each problem. A sensing problem is to define the input or search space. So feature selection problem, human can do it, okay? If you use so this method to AI have to change the parameter. It is very difficult. Maybe so please try to use the current AI to solve these problems. So anyway, we solve different problems with different weight parameters. This flexibility is human intelligence. Okay. So here, so we can discuss 2 AI approach. So one is clustering. So in case of clustering, so we never say have to divide. Okay. So this is my question given to you. On the other hand, if I give you just only X and Y, and so each area's color. Okay. So here we explain how to divide. Oh, please divide a blue point from green point. Okay. The input is X and Y. Output is color information. So this is classification problem. In the previous lecture given by Rausi, so he explains unsupervised learning. Okay, so here there is no supervisor, there is no teacher. We just give you some data only, and then you can find the boundary. So this is a clustering problem. On the other hand, I give you the teacher signals. Oh, this is green, this is blue, and others. And then so this is supervisor. Okay, supervised learning. So please remember these 2 approaches. Of course, so you know that, but so this is very important to know the basic idea of AI. Okay, so what is intelligence here? So in the beginning, I explained that our sensing mechanism is related with awareness. So here is attention mechanism. So feature selection. So which space is used, which space is not used. Okay. So in the second level, in case of perception, so clustering, we try to find the border or boundary. And then after that, so we can discuss what is inside of border. Okay, so this is classification. So how about
okay.
Okay.
OK，好，大家把这一段拍下来。Can the student take photo? Take this photo. The student take photo.
Yeah, yes.
OK，大家把它拍下来。好，这个是那个大家写那个期中考试要把这一页写进去。我发现那个这个 PPT 是学长都没跟我去，我自己想去，我就拍了很多照片，我丢给他，他解释出来的99%都是对的。你懂？他没有去听演讲哦，就是我把那个演讲整的那个头里面丢进去，可是我是有付钱，是有付费的。他解释出来99%，而且是用台湾的语法，不是用中国大陆，也不是用马来西亚，也不是用香港的语法。他现在会侦测说你现在是在哪边？你在香港，他用香港的语法，现在已经很厉害了。所以你看，很多工作不用人做了，以后我们周休3日，周休4日都有。真的，我们可能一天只要工作3个小时就好了，其他都交给 AI 去做。那这一页把它拍下来，有修我的课的，什么是 intelligence？ 刚刚不是要去定义吗？什么是智慧？可能是人工智慧。然后什么是认知？认知，比如说老师刚刚穿外套，现在觉得有点热，就把外套脱掉。那个周宝田老师，我问他为什么没穿西装，他说那个柯立伟教授跟他说台南今天30度，然后30度很热，所以他都没有穿。他明天看到在阳明交大国际会议今年讲，他就要穿。就是这样。所以这一页就 future attention 最下面那边有个 ATT attention 这个老师等一下会讲 attention， 所以不管是刚刚 OPPO 老师讲的 attention， 或者是中华人讲的 attention， 一个是接触式，一个是非接触式，一个就是有给你答案的，让你去写的，一个是没有给你答案的，一个是 superhuman， 一个是 superhuman。那我们用人的语言来讲比如数学系比如说经济或是在做数学运算，对，那我们先用人的观点来看人工智慧。好，那
Okay. Yes. Okay. What this? Okay. So this is a general understanding of visual information processing. Okay. So what is visual understanding? So in the standard computer vision or computer okay, so robot vision or computer vision. So we try to use this kind of raw data as digital signal, and then we try to extract some features. The features is like this. It's information or something. Okay, so I obtain this one. Which do you think? This A or H? A. H. Okay. How about this? What is this? H. H. H or A? A. Okay. So how about this? H or A? Okay. Okay. So this is amazing. Okay. So safely, I explained. I show the movie in the beginning with no sound. Okay. So safely to discuss. So this kind of pattern recognition in 1955. This is really amazing. Okay. So I think he is one of pioneers in computer vision or artificial intelligence.
So now I explain. 大家知道那个周宝田老师在讲这个 context 要上下文嘛，所以你是 A 或 H， 你可能很难判断。可是你如果是 THE， 第一个你就判断是 H 嘛，第二个是 CAT， 因为我们知道，听懂我一下这人类智慧 ，A 跟 H 你把上面叠掉以后，那这是1955年就提出这样的一个想法了。那到现在大家都已经可以做得出来，那时候提出来其实大家觉得说要做什么，没有人知道要做什么。这样知道就是 A 跟 H THE 嘛 CAT 有没有？你就会判断了，这个可能是 A， 这可能是 H。如果都没有上下文的话，你就很难判断。这人类的认知嘛。好
Okay, thank you. Okay, this is the context level of fuzziness. So how about this one? A or H. Okay, so please read carefully.
H
A or H. Okay, H. Okay. So cylinder head temperature. Do you think a current AI technology can recognize this abbreviation? Do you think AI can do it or no? Okay, yes? No. So actually, so this example is very simple, but so in general poster, okay, there are so many different keywords and some figures. At that time, it is really difficult to find the relationship between CHT and its corresponding to original meaning of cylinder head temperature. Okay, so this is cognitive level of fuzziness. Okay, so it is very difficult. Okay, so how about this? Have this. Have this. Can you say? Have this. Have this.
I S 十的，来，好，这个你觉得是什么？A，对啊，你要去日本，那日本老师他们上课是这样，是互动式的，不是我一直在黑板或白板上写，你们一直在抄，我们希望是这样互动式的 A 嘛，好 A，she said，
Yes.
because she will go to Japan next year to use technology master.
Okay. Yes. Yes.
So I asked the student, she said.
Okay. Good. So here, yeah, this is human intelligence. Actually, so here is hidden. Here is hidden. Here is hidden. Okay. If so, we clarify so hidden area, so we can understand this character. Okay. On the other hand, here, so this is hidden or not, we don't know. But if we clarify the hidden point, so we can understand. So this is human intelligence. Okay, so Professor Fukushima, so he is a father of deep learning or so that kind of architecture. Okay, so he proposed so this method, neocognitron, so almost so 50 years ago. After that, he proposed this attention mechanism, maybe so 15 years ago or 20 years ago. But so this method can do it if we clarify the hidden area. So this method can recognize characters. Okay. So how about this? R B. This is point. Here is nothing. Okay. Here is nothing. This hidden area. So this hidden area is not clear, but here is nothing. Therefore, so we can recognize this character is R. On the other hand, here, so this area is empty. As a result, so we can estimate, so this character is B. So in this way, where is hidden? Where is not clear or not clear? And then, so we can estimate this character. So this method, so neocognitron, I can do it. Okay, so how about this? Have this. Have this.
Apple.
Yeah, Apple. It's easy. So first, so you find the boundary, and then you identify the inside area of the boundary. Okay, and then you say Apple. Here, this is linguistic intelligence. So Chanshin said apple. Why don't you say fruit? Why don't you say food? Of course, this is food. This is fruit. Why did you choose apple?
I explain. 他问说这是什么？他是个苹果，对不对？他你们怎么说它是水果？你们怎么说它是食物？可以吃嘛？可以吃嘛？对不对？你讲水果对不对？也对呀、啊。你讲食物对不对？也对呀、啊。我直觉就讲苹果，因为这个他已经讲过很多次了。说那maybe the previous
OK，
福库西嘛。其实这样的想法是在1979年、68年，我小学6年级的时候，我那时候你们应该都还没出生，福库西嘛老师提出来。那时候这是竞争引发的，可是全世界都还那一边哪份还没有提出那0到9的变质，所以你们今天的作业是按0到9的变质。他是一个很老日本的教授，那时候提出来，其实做一个研究，大概到20-30年以后，大家才会知道这个研究一下。现在可能大家你做的时候，可能说都觉得是没那么。所以你看那个可以是 B 也可以是 R 嘛，哦，你把它遮起来，那 A 一看就知道，你下面这个可能是 R 也可能是 B， 就看你的那是我们的认知嘛 ，OK？
Yeah.
对，那刚刚9毛田老师问我就说这是苹果嘛，我觉得是苹果。他说你为什么不讲说它是水果？也对啊，你为什么不讲它是食物？也对啊，其实都对嘛，对不对？你也不能说讲水果就是错的，对不对？所以真实世界其实是不会只有单一的标准答案。可是我们亚洲的学生训练出来就是标准答案。你讲一下你的是不是从小训练是它标准答案，对，可以，那个标准答案。可是真实世界其实。
Okay, so this is visual understanding. So in case of visual understanding, first we try to find the boundary and then we try to identify the inside of object, okay? But this. yeah, it's very interesting. So can you find the guitar? Actually, so there are many different animals, but there is just only object here. this is amazing. Okay, so so Esha. So please find this figure at the web page. Yeah, we can enjoy. So anyway, if there are apple and orange here, you may say fruit, but this is just only one type of fruit. Therefore, you say apple. So you try to use the most suitable keyword. This is human linguistic ability. So in case of current AI method, of course AI can say apple, but there are orange and apple. AI say orange and apple. I think no, AI does not say fruit. I think. Okay. So what is cognition, perception, and sensing? Okay, so here, so actually I already used some 30 minutes, so I have to hurry up. Okay, so here,
10 minutes.
10 minutes. Okay, so we can use inequalities to distinguish these two areas. Okay, and then so we can use two inequalities. So like this. Okay, yeah. This is the very basic mathematics in high school. Junior high school. Okay, so here, so we change these two inequalities to if-then rule like this. Okay, if x2 plus x1 is larger than 2, then so y1 is 1. This is output. Okay, this is input condition, and this is output. Okay, and then after that, if y1 plus y2 is equal to 2, then let. So this is our inference. If we represent this kind of inference by using network model here. Okay, so this is our first equation. So this is a second equation. This is third equation, and then input is x1 to 2, x1 to 2 and 1, x2 to 1, and like blah, blah, blah. Okay, so this is a basic neuron model. Okay, if we use so many neurons, if we use so many layers, so we can conduct inference. Is it true? Okay, so here. Okay, so what is understanding? I said, so segmentation and identification. This is a basic idea of understanding. Okay, so here, this is neural model. So I hurry up. Okay. I don't have time, the exercise I prepared, but okay, anyway. So here, the input is here, the weight parameter is here. Weight is very important to pay attention to something. Okay, so here, if this W is 0, this input is not used. Okay, so in this way, so if we change the weight parameters, so we can do many different types of inference. Okay? So here, the output is like this. So W, so weight parameter times of so X, so like this. So if the sum of, so this in this equation is larger than threshold theta, then the output is here. Okay? So this is very simple. So this is logic or so digital circuit example. So this is AND operator. X1 and X2 input output is Y1. So here, so by applying so this approach, so we can write so like this: x1 plus x2 is larger than 0.5. Okay, so, like this. So in this way, so we can write the weight parameter plus one. Okay, so this is the sum of these two parameters, and then this value is larger than threshold, and then output is 0 or 1 or minus 1. Okay, this is very easy. Okay, so how about this? Or this is similar. So I skipped the detail. Okay, so if x1 plus x2 is larger than minus 0.5, so we can obtain this result. So how about this one? Now, so I gave you the answer in this slide. Here, minus, okay, minus x1. So here, input is x1, but here, so minus 1 is used here. So minus x1 is larger than something, and then output is plus 1 or minus 1. So here, weight parameter is minus 1, the threshold is 0.5. In this way, this is negative weight parameter. If we can use negative weight parameter, we can change the result reversely. Okay? So how about this? So actually, so I don't have time. So please, okay. So this is homework. Okay? Homework. Okay. Yeah. So this is traditional calculator, pocket calculator. Okay. So this shows 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So here, so if we use a if we turn on this area, okay, its corresponding result is black. Okay, so in this way, we can represent like this. Here is black, here is black, here is black, here is not black. No black, so white area is 0. In this way, we can represent these 10 characters, so like this. But this is really long, really long. So we can reduce, so this binary data. How can you reduce? Okay, this is a homework. Please consider. Okay, so here. So if we use, for example, if so these two are turned on, its corresponding result is 1. If we use 3 black, this one, and this black, so these 3 are all black, is 0. So here, this is white. Therefore, so this is not satisfied. The other result here is 0. Okay, so these two are black. Okay, and then so its corresponding result is 1. So in this way, we can represent the character 0 as 1, 0, 1. How about this one? Okay, 0, 0, 1. Here is 0, 1, 0, 0, 1, 1, and others. But if you decode 0, 0, 1 to real character, for example, if you receive 0, 0, 1 at that time, how can you decode this data? Okay, or 0, 0, 1 is corresponding to 1, 7, and 4. We cannot decode. Okay, how can you represent these data? Okay, so this is a point. And also here, if you use three binary numbers, its corresponding combination is just only 8. Therefore, we cannot represent all characters, so 10 characters, by using 3 binary data. We need one more. Okay, so you can use this kind of data. This one and this one are black. This one, or so we can choose So any type of features, and so we can combine these features. Okay. So this is homework. This is homework. So I skip the detail. Okay. So I will finalize, and then so this is my answer. Okay. So first one is here. The first feature is here. So this is included in here. So one. Okay. This feature is not included here. Okay. So and then this feature is included here and not here, 0. Okay, so here, so this feature is included here and then 1. In this way, we can represent 1 and 0, so like this. But this is not enough. The third one is here. So third feature is here. Okay, this is included. Therefore, so third binary code is 1. Okay, so here is also 1. Okay, 1. Here is not included and 0. However, so here you can find the same code 101 here, 101 here, 000 here, 000 here. Okay, here 010, 010. How can you solve this problem? By adding one more binary feature. So I found this one. Okay, this feature. Okay, if this is included in here and the fourth bit is 1, 0. So this is included here, 1. So as a result, we can represent so all characters by using 4 different features. Okay, yeah. This is answer. Okay, so here, so go back to the definition of a neuron model. Okay, so here, so this is included here, and then so we can write the weight parameters here. Okay, so hurry up. So input is here. So this feature is included or not. Okay, included or not here, and then so weight parameters here. So in case of 0, okay, I represented 0 as 1, 0, 1, 1. Okay, weight parameter is here. So 1 is here, 1 is here. Second one is 0. Second feature is not included in 0. Therefore, I use -1. Okay. A feature is included in the character. We use the positive weight value 1. A feature is not included in the character. We use the weight parameter, so negative parameter -1. Okay, this is the point. And then, so in this example, all 0. Therefore, the weight parameter is all -1. Okay, so here, so by calculating this one, and then if the output value is 4, it's corresponding to the character. Okay, so I show one example. Okay, so here in this example, okay, so here, so this value is included here, and then 1 here is -1. Okay, -1. So the third feature is included, therefore 1. The fourth feature is included 1. So I mentioned before the weight parameter is 1, -1, 1, 1. Therefore, so 1, -1, 1, and 1. As a result, its calculation result is 4. Okay. On the other hand, in other example, okay, so we obtain -2, 0, 2, or something. As a result, this character is recognized as 0. Okay, it's very easy. Okay, in this way, if we focus on some feature and then we can extract some combination of features, as a result, we can recognize that is okay. What is that? What that is? Okay. So here in this example, so in case of character A, so this area is included here. And as a result, we can recognize this character as A. So feature is here. the combination of something. And also here, so the size of character is different in the written letter. Therefore, we try to use different size of characters and also different shape. Okay, a little different shape is also included in this area, but the same character is included in this area. So in this way, in the beginning, we try to find the basic features, and then so we combine some features in the higher level. As a result, we recognize the character. This is a basic idea of neocognition. So Fukushima Laosi proposed this idea in 1999, 79, very old. Okay. Okay, so this is the root of deep learning method. Okay, so I skipped the detail. So by using this example, I explain. So in the beginning, so we try to extract some edge information. By combining these edge information, we can obtain this kind of features. So you can find these are the facial parts, some facial parts. So by combining these facial parts, so we can obtain this kind of result. This is similar to human face. So this is a basic idea of deep learning method. Okay. So in this example, okay, so we designed, okay, in the previous example of character recognition, we designed the feature in the beginning. Okay, so and also in the previous example, so draw line or something. At that time, we try to use some features explicitly. In the beginning, we have to extract the features and then we learn how to combine the features. This is human intelligence. But so in this approach, so the deep learning method, we don't need to design features. This layer extract automatically. This layer extract automatically these kind of features through the learning or training. So as a result, so we can realize visual intelligence technology. Okay, so here. Okay, yes. Okay, let's explain the method of classification at the previous class, and now so I explained so how to use clustering method. Okay, so here, as I mentioned before, the input is all data, and then we try to find some boundary. So how to find boundary? This is the aim of clustering. Okay, I showed this example. Do you remember that? So here, so we can find three clusters. So like this. Okay, it's easy. Okay, it's easy to make a cluster, make clusters. So by using human visual intelligence. But in fact, we have to deal with this kind of data. Okay, how can you conduct clustering by using these data? Okay, we have to calculate some distance by using these data. Okay, so this is a clustering problem. So first, so I explained this example. So in the clustering, we try to obtain a set of centers. In the previous example, okay, so I go back here. So we found three centers. So here, here, and here. Okay, so this is the aim of clustering. How about this? If one cluster, okay, if we have one cluster, so we have to use this center. But so you never agree with this center. Why? How about this? At this point, do you see this the green point near to the data region of this blue point area? This is near to this data. Actually, so difficult to answer. This is near. Why? So we consider some kind of distance from the center of data region or data distribution. Okay. So here, if we use two clusters, the centers here and here. In case of three clusters, so we obtain these centers here, here, and here. In case of six clusters, so we obtain these centers. Which is the best? So this one, no. This one, no. This one, which is the best? Maybe so. This is also difficult to answer. But so this one or this one will be fine. So we think. So this is not so good, I think. Okay, why? So most of students selected this one. Okay, this is the best. Why? So now, so we consider two features in clustering. The first one is internal cohesion. Internal cohesion, this means so intra-cluster distance. Okay, intra-cluster distance. So here is the center. So we can calculate the distance between this center and the data. So like this, we can minimize. So we should minimize the distance from the center. Okay, from the center to individual data, like this. So here we give this data sample. We try to find the nearest center. Okay, nearest center. As a result, so this data join to this cluster. So in this way, so we can discuss internal cohesion. Okay? The aim of clustering is to minimize the distance to individual center. So by using this one, if this data join to this one, okay, this data, if this data join to so this center, it's corresponding. So result is one. Okay, this if this data does not join, okay, this point does not join. So this center, its corresponding relationship is zero. So in this way, we can sum up the distance by using this equation. Okay. So here, so RJK is important. The aim of clustering is to find the nearest center. So RJK is 1 or 0. Okay, so here we compare these three examples. So how about that? Maybe so you think this is better than this one. Why? So I define this function, the distance, the sum of distance from each data to its corresponding center. Okay, so the center, this center is a little far away from this data, As a result, the sum of distance is larger than this example. In case of three clusters. Okay. So how about this? Please compare so this one and this one. So do you think C is better than B? Okay, so here. So B is better than C. Which is better? Okay, so by using so this distance information, so its corresponding distance, okay, the sum of distance, the sum of distance is larger than this one. Okay, so the distance from this center to this data is small, very small. As a result, so as you can see, so this function is satisfied. If so, this is better. However, so in our understanding, we should use so isolation, the idea of external isolation. The distance between center should be maximized. So here is near, okay? So these two clusters are near each together. These two are near each together. As a result, so we should choose this example, okay? So this is a maximization function. So inter-cluster distance, okay? In the previous example, shows the inter-cluster distance. So here, inter-cluster distance. We should maximize the sum of so inter-cluster distance, okay? So here, according to this discussion, the distance, okay, the distance is larger than here, yeah, which is better. Actually, so average distance, I mean average distance, okay, which is better. Maybe, so this is longer than this one, this example. On the other hand, this is better. So because in this example, we focus on uh, external so isolation. So here, okay, that's enough. That's enough. I will finish that. Okay. Okay. So here, the inter-cluster distance is shorter. So here, inter-cluster distance is larger. So in this way, so we can discuss these two factors when we consider the clustering. Okay. So here, okay, so this is just last two or three slides. So here, so we try to minimize so inter-cluster distance. How can you do it? This is a squared distance. Okay, this is squared distance. Therefore, so we can use a first derivative of so this function. So by using optimization method, okay? This is very simple one. So we obtain the derivative so from this function. Okay, so round f, round w is like this. So here, so we obtain so this equation, linear equation. This is very simple. So we solve this linear equation related to wk. So wk is the center of cluster. We obtain like this. So here, so in this way, so we obtain the result of the center of each cluster. But we still have a problem. Have to decide RJK. So this is membership. Membership means so this data joined to this cluster or something. So 1/0. So we have to optimize RJK. Okay? So have to decide this one. This is also easy. Okay, so I skip here. So therefore, so in the beginning, so we try to choose three data. In case of three clusters, we try to three data from the data set. Okay, so this is K-means algorithm. Okay, so we just so obtain the procedure of learning algorithm of K-means algorithm. So in the beginning, we just select three data randomly. So in this example, 1, 2, 3, and then so we give some other data okay, some other data to these three centers. And then, so we find the nearest center here. Okay, so the fourth data join to the first center. So in this way, so we obtain this result. So we obtain the nearest center from individual data point. This is very simple. And then we calculate the center of gravity or center of data. So as a result, so we update the center of data. So here, here, and here. Of course, by using the number of points, by using this method. So I show the procedure of k-means or clustering method. In the beginning, so we just set the three data randomly, and then we obtain the nearest center from individual data point, and then we calculate the center of cluster. Okay, and then we calculate the nearest center from individual data again. As a result, so we obtain the same structure. In this way, we finish the clustering algorithm. This is really easy. Of course, so you can use a library from the R software or so Python, but you can make clustering algorithm by using your brain. If you understand the essence of your visual understanding, so you can you can build your own method. So this is my message to you. So before using so AI library, please your brain. Okay. So here initialization, assignment, update, and then so we obtain the result of clustering by using internal cohesion and external isolation. Okay. So this is okay. So this is my talk. So anyway, so I have to. So I finished the presentation mode, and then so I cannot go back to the slide back. So so my message is to use your so build your new method for your future. Thank you very much.
Okay.